Perseverance's sample caching system was specifically designed around the assumption that only subsurface rock could preserve biosignatures reliably. The deeper the evidence is buried, the safer it stayed, and harder it became to reach. Drilling deep into Martian rock requires equipment far more powerful than anything current rover carry. Perseverance's drill can only reach a few centimeters into the ground, while the most promising evidence may lie meters below the surface. NASA engineers have publicly stated that Perseverance's drill was designed for sample collection, not deep subsurface exploration. Inside Lander's digging system illustrated how difficult it is on Mars to penetrate into the ground. What Earth's rivers and storms eventually uncover, Martian dry, still ground keeps buried for good. From orbit, the next big clue on Mars will not come from a rover, it will come from a satellite spotting where to dig. Unlike rovers limited to a small radius, orbiters can survey Mars's entire surface for the best possible drilling candidates. NASA's Mars Reconnaissance Orbiter has mapped the planet's surface in detail since 2006, covering terrain no rover could reach in a lifetime. Long before Perseverance landed, its landing site was chosen from orbit. Landing site selection required years of comparing dozens of candidate craters, a process only possible through orbital surveys. A rover's journey on Mars is not about distance, it's about surviving each carefully chosen step. A single wrong step, like getting stuck in those sand, can end a mission entirely with no way to send help. In 2009, Spirit rover became permanently stuck in soft sand at the site later nicknamed Troy, ending its mission in 2010. Millions of kilometers of successful travel undone by a few centimeters of hidden sand. The most dangerous ground on Mars often looks like the safest. Even high-resolution orbital imagery cannot measure ground firmness, only surface appearance, leaving hidden risks undetected until it's too late. Spirit's Troy sand trap looked no different from surrounding terrain in high-rise images. taken before the rover got stuck. Following Spirit's incident, NASA introduced TAP tests, having rovers physically test suspicious ground before fully committing to a path. NASA did not just learn from Spirit's mistake, it built a new rule around it, using ground-penetrating radar like on Perseverance. Every sensor on Perseverance exists because Mars already proved what could go wrong. Its six-wheel suspension was redesigned after Curiosity's wheels suffered unexpected damage from sharp, unseen rocks. By 2017, Curiosity's wheels showed significant wear, with some treads completely broken after years of unexpected rock damage. Mars tested Curiosity's wheels for years. Perseverance was built from everything that test revealed. Wheels can survive rocks, they cannot survive Mars's relentless temperature swings. Repeated thermal cycling weakens metal joints over time, making materials brittle even without any physical impact. Data from Viking landers in 1970s first showed how repeated cold exposure could weaken mechanical seals over time. Even the earliest Mars mission knew the cold would be as dangerous as the terrain. Minus 63 degrees Celsius is the average temperature on Mars, but the extremes go far colder and far faster. Infrared energy absorbed by the ground during the day passes through the sparse carbon dioxide layer within barrier. Curiosity rover measured a 70 degrees Celsius drop in ground temperature at Gale crater within a single night cycle. These rapid thermal swings make liquid water on the surface physically impossible today. Still, the absence of stable surface water does not mean that the planet lacks water altogether. Water below the ground would not experience the same rapid heating and cooling that makes surface water unstable. Phoenix lander found water ice beneath the Martian surface in 2008, showing that water can survive below an unstable surface. This turns the subsurface into the next place to look when asking where Martian water exists today.